13:50. So Derek, how's it in Richards Bay? How's the weather?
The weather's fine. We've been through a very difficult week, as most of KZN has. Yeah, but we're glad we're into this week.
I'm glad you're all safe and bounced back.
Yeah, we are. Yeah, we are now. Thanks.
That's great. So for how long has the Science Center been running? Because I feel like it was really a long time ago since we first started.
So our Science Center will turn 35 this year. So it actually started in 1986, and I've been with it on and off since 1988. Just with a 3-year gap when I went science teaching. Yeah. Now, of course, the great tragedy is that for the last year and a half, we haven't been able to have visitors. But in a way, that's why we, have done so much stuff in video and online and so on, as we spoke about in the last session, because we just can't get visitors in. Unfortunately, hands-on interactive exhibits are the worst possible thing for COVID, and bus trips for students and so on. So science centers worldwide haven't really found an answer to that.
I suppose the answer is that we just need to be adaptable,
It is true, but the problem is that, there's something special about hands-on interactive exhibits. And when a student explores something by himself, and this heuristic learning, discovery-based learning, it's never the same when you're having it mediated by someone else, or like now by a machine that's in front of you. It's just never the same. I think especially for rural children, to be able to have that hands-on experience with equipment, which doesn't happen at school. So we do the best we can, but obviously we would just love to see pupils face-to-face again.
Yeah, I suppose the whole idea of the Science Center, it's that community feel and that atmosphere and the interactive.
Absolutely.
Exhibits.
And I think presenting science as a human enterprise, not just something by machines. And
not humanoid.
What I consider the best science center in the world, the San Francisco Exploratorium, the founder, Frank Oppenheimer, used to say, first of all, you can't fail a visit to the science center like an exam. And secondly, when a child leaves, nobody can say you're not a scientist for this or that reason, because the child will say, but I've been doing science all day, so I'm a scientist. Tremendously empowering. And we can still transmit information, but that empowerment is so much more difficult now.
And I still remember all the adults playing with the exhibits, including myself.
Yeah, well, we are open to children of all ages.
That's awesome.
Yeah.
Okay, we have 24 participants. Derek, if you're ready to go.
I am, and thanks very much, Krishni. And I think most people have been in the last session, so you have the terrible trauma of having 2 hours with me today. I really apologize. I'm not going to put up a PowerPoint and give you further death by bullets, but hopefully just show you some of the exciting ways to make science lessons more exciting. Now, I must be honest, I'm a bit frustrated with the medium we're using of a webinar, because it would be really nice if we could actually see all the participants and take questions and so on. So I think what I'm going to do is present a little bit of material and then stop the screen share so we can talk about it a bit, and then present a bit more and so on. I'll be honest, I've got tons of stuff to show you. I have no idea exactly how it'll go or how long it'll take, but we'll just see how it goes. So please do feel free to use the chat. Do feel free, and when we break, put your hands up, and obviously a live question is so much better.
So Derek, just before you begin, sorry,
sure.
Sorry, I just want to remind everyone we are in room 3, and the title of your demo is Beyond Facts, Finding Fun in Physics. Over to you, Derek. Right. Thank you.
Okay. So I wonder how many of you remember William Smith's science videos, which came out in the 90s. And in many ways, they were very good, but they were basically talking head videos. And I was determined not just to do the same. So I started looking at lots of the simulations and things which are available. Now, these simulations can really be used in different ways. you can record them and present them on a video, or much better, the teacher can actually use them live with the class, because then you can ask lots of what if questions, or even better still, the pupil can actually explore them themselves. I'm just going to share a screen here. And Krishni, please stay online so that you can tell me if everything is visible. Just give me
Will
a
do.
sec. Yeah. So many. Okay. Okay. So Krishni, are you seeing my PHET screen, the web page?
Yes, I can see it now.
Okay, right. So again, for the teachers who are here, if you use PhD extensively, I apologize. But if not, I want to tell you about it. And if you do know it, I want to tell you some more about it. So all you need to do is Google PHET and you will find it immediately. This is something which is done by the University of Colorado in Boulder. And it's interesting to see a little bit about the background. This was founded in 2002 by Carl Wieman. Now, Carl Wieman won the Nobel Prize for physics. So he's a really distinguished physicist. And, you know, you get quite a lot of money when you win the Nobel Prize for physics. But he and his wife decided that they didn't need the money, and they used it to set up PHET. And PHET is now used millions of times around the world every year. You can see there, it's translated into 95 different languages. But the real strength of PHET is it's almost entirely independent of language. You really don't need any language at all. Now, you can use PHET while connected to the internet. So, for example, I could click on Explore Our Sims, and it would bring up all the different simulations that are available. And you can see there's some physics ones, and by clicking on those, we could go into them. So I'm using this connected live to the internet, but you don't have to do it that way. What you can also do, if you go to the end of their web page, you can see offline access there. And if you click on that, it offers you the possibility to download the whole of PHET to your computer. So you just choose your type of computer there, and you can download it. It changes from time to time, but it's about a 250 megabyte download. It's not too bad. And once you have that, then all of these sims are available on your computer, which is very useful. What PHET has also done recently is they've provided an app, and I'll put it up on screen now. Just a sec. I'm just going to have to make sure that I'm sharing the right thing. Hare Krishna, you're still on my web page there?
Yes.
Okay, I've just lost my, oh, there we go. Okay, so I'm just going to change my share here. Just give me a sec. Sorry, it's really tricky juggling all these things. Okay. Okay, let me leave that for now. But they've got an app so that you can actually get to the sims much more easily. Now, I want to just show you a couple of the simulations, and let's just go through them through the web page. So let's say I'm about to teach a section on electricity. Okay, so I'll click to bring the simulations up on the page here, and you can see there's physics. And let me untick everything except electricity. Just a tip here, you can see this compatibility. They've been programmed in various different languages, and I suggest you just click all of these, okay, assuming that your computer can actually handle Flash, Java, and so on. Unfortunately, there are some problems with Flash no longer being supported, but there are ways around that as well. That's a technical thing that you can Google. But let's say we start off and you're just teaching a class on electrostatics. So we can start off with John Travoltage here. So they got quite a nice sense of fun in what they do. And you can either download it or we could just play it directly from here. So it's really not very hungry on internet, but as I say, it can be downloaded completely independently. Now you can see there's no instructions on screen, but what we have here is John Travoltage. You can move his hand, and you can also move his foot and rub it on the carpet. Now you can see what happens. It's showing what happens. I think it's very familiar to everybody, getting a shock from a doorknob after rubbing their foot on a carpet, for example. And we can also put a little bit of charge in, not quite enough to get a shock. You can see the electrons repelling each other. If we bring his hand a little bit closer to the doorknob, and so on. And this can be a point of discussion, just to talk about what's happening here, how is charge transferred, and so on. So that's a very simple simulation. The idea is a conceptual understanding. Then maybe we could jump to this one on balloons and static electricity. And again, Krishni, just so I can be sure, you can just confirm that the balloons on the jersey are opening up. Just give it a second. So Krishna, you got a
Yes.
picture of a jersey and a balloon? Okay. So of course, if we take all the charges away, I think everybody's familiar with the fact that if you take a balloon and rub it on a jersey, it will actually stick to that jersey. It'll also stick to the wall over here. That's quite an interesting discussion to have with your pupils. What's actually happening here? And how does the balloon get charged and so on? Let's reset the balloon. If I rub it on the wall, then actually nothing particular happens to the balloon. So let's show all the charges and let's see what happens. So obviously you've got positive protons bound up in the nucleus, not free to move. You've got negative electrons that move quite easily. So let's rub that on the jersey and what's happening? Okay, so we have charging by friction here, and those negative electrons are actually rubbed off the jersey onto the balloon. So the balloon has an excess of negative charge. Jersey has an excess of positive charge, and positive attracts negative. But what about this wall that's neutral? What's actually happening there? Look what happens when we bring the balloon closer. And you can see you get a temporary induced charge there. The electrons are actually repelled by the balloon, wherever it is. You get a temporary induced charge, which allows the balloon to stick there. So it's a really great way of actually talking about this process. And again, if you use it, I encourage you to start off without showing any of the charges. Just looking at what happens. Because of course, electrons are not visible. And what can you actually do? How do you understand what is happening with the balloon here? Now, again, as I say, those are both purely demonstrations, but then we can get a little bit more quantitative. So, for example, we could get to Coulomb's law. So obviously, this is only taught in grade 11, but Coulomb's law allows them actually to do some calculations here. So now we've got something which is quantitative. They can do calculations based on it. And this gives them a good idea of how an inverse square law works. Just give it a second to open. Okay, so on the macro scale, again, Krishna, you're seeing the Coulomb's law picture with the two charged objects?
Yes.
Okay, great. So here you can see two charged objects. There's some forces. And what I like about PhET is it's very correct. So we don't like to say the force between the charges, the force on Q1 according to Q2. Now you can move things around. If you move these closer, you see that the repulsive forces get much bigger. If you move them further away, repulsive forces get much smaller. You can also change the charge. So let's take charge 2. Notice the force is 594 newtons. Let's change it from 8 microcoulombs down to 4, and we can see that the force has halved. You can show very nicely that force is directly proportional to charge and inversely proportional to the square of the distance between them. Now, of course, one very seldom gets very big charges in nature. So you can also look at an atomic scale. Now you can see the charges are actually in microcoulombs, just number of electrons, are actually in electronic charges, and the forces are in micronewtons. And again, by moving them closer and further apart, it really makes a point nice and clearly that basically every charge that holds nature together is at its heart a Coulomb charge. And let me just go to one more of these. And of course, later you get to charges and fields and looking at electric fields, which is a little bit more complex. Now, it would be wonderful if everybody could do an experiment to create a real electric field, but it's quite a tricky experiment to do, especially here in Zululand where it's quite humid. So here we have the electric fields. And if I just take a charged particle, 1 nanocoulomb charge, I can ask it to draw the electric field around that charge. You can see as I move it around, the electric field responds to that. Now, when pupils are learning electric field patterns, again, there's 3 ways you can use this. You can record it in a video, or the teacher can demonstrate it, particularly if you have a projector, but otherwise from a laptop, or better still, students can use it. Now let's switch off the electric field and let's put in a negative charge. And students can be asked to draw what the electric field would look like between two charges. And of course, we can switch it on, and you can see very nicely how the shape of the electric field changes. And of course, you can introduce as many charges as you want. And as you introduce and move a new charge, the whole electric field changes like that. Now, the idea of electric field strength is based on the force experienced by a unit positive charge. You can put that unit charge in, and you can see how that force is shown very nicely. Always away from positive, always towards negative. If we get rid of the negative charge, put in the positive charge, you can see that if we take our test charge right to the center between them, then the force actually drops right down to 0. So there's no electric field. Now you can see from a conceptual understanding point of view, this is a fantastic way to explore these. And really, I shouldn't be showing you these. You should be exploring them yourself. And you can just go to PHET and actually explore these things. Now, I'm just looking at one topic at the moment, okay? I'm just looking at electricity. And some of my favorite ones are these circuit construction kits, because you can actually build a real live working electric circuit. And that is really great. So let me click on one of these. And again, it's fantastic if you've got ammeters and voltmeters and you can do everything. But failing that, if you're not able to do it, this is a really nice way to actually do your circuits. And everything works, and everything works perfectly. You have no flat batteries, you have no blown resistors or ammeters or anything like that. I'm just opening this here. I'm sorry, because of the share screen issue, it's just much easier to open everything from one web page, because otherwise we get complicated. So Krishna, are you seeing a mostly blue screen?
I'm still on your web page. It says circuit construction kit.
Okay, that's why I need to ask. Just give me a sec. So let me see if I can just go to, now are you seeing it?
Yes.
Okay, it's very tricky to keep track of things. So you can see all you do here is you do what it says, you grab a wire, and then we can put a battery on the wire, and we can put a switch on there, and then let's put in a light bulb. Let's put in a second light bulb. I'm sorry, it just takes me a few seconds to build a circuit, so just bear with me. But you can see I'm connecting all the different parts of the circuit, and we're going to end up with a live circuit which actually works. Just give me a sec while I finish my circuit. I'm making a parallel circuit here. And just joining the different parts. Now you'll notice these wires also have electrons in them. And what's great is these electrons actually move. So there we go. So my circuit is complete. So if I switch the switch on, you can see the circuit actually works. Now what's so great about this is if you see the fact that the electrons actually travel faster in the main circuit than in the smaller circuit. And there's various different ammeters that we can connect here. And let's bring in a voltmeter, and we can connect the voltmeter to different parts of the circuit. So for example, connecting across the battery, we can see that that reads 9 volts. Okay, so there are advanced tools as well, all kinds of different things, but you can show very nicely that, for example, the voltage across we've got some resistance. Let me just get rid of resistance in the wire. That with a parallel circuit, the voltage across the bulbs is basically the same as the voltage across the battery, give or take the resistance that's in the wires. Now, you can see you can build series circuits, parallel circuits, you can use AC, you can use DC, you can use all these different tools, and everything actually works there. You can also say, for example, well, I wonder what would happen if I took a wire and I connected it across here. I want you to think about it before I connect it. What is going to happen here? Will the circuit continue to function? What will happen? So let's connect it there. And you can see actually the battery goes up in flames because we have a complete short circuit there and it ceases to operate. Okay, so I'm just going to stop the share for a minute. And as I say, that's just on the topic of electricity. Those are some of the different PHET simulations that are available. The only way to learn to use them is actually just to try them. That's all I've done is played with them. Now, Christian, I'm just going to pause for a minute. I've got tons more to show, but it's just difficult to take questions while I'm sharing screens. So just
We can
whether they,
take.
I can see some things in the chat, but I'm very happy to answer
They're
questions.
not. Sorry, they're not exactly questions. I
Yeah.
think there's.
But if someone has a question and you want to raise your hand and go ahead, this is a great time to do it. Otherwise, I'll continue.
So the one question is that can Derek record a video on this for teachers?
Okay. Well, the one thing I can say is Derek has recorded 16 hours of video, which I talked about in the last session, which use PHET simulations extensively. So those are available, and I gave all the links in the last session. But otherwise, I will pop my email into the chat again, and you're welcome to contact me afterwards. But as I say, no one needs to teach you how to use PHET except yourself. You just need to try it. It's so easy to use. So any questions while I pause for a minute?
So there were some requests for your email. So Derek's just put the email on the chat.
Yeah.
So if you have a question, raise your hand or just unmute and ask or type it in the chat, please.
Yeah, please don't be shy, because really this should be an interactive workshop. And if I'm just talking all the time, you're not going to get much. I'd rather answer your questions.
Derek, my name is Robin Naidu. I'm not a physics person, but I'm listening with interest and I'm fascinated by what you're showing. First time I'm hearing about PHET. How early can this be started with young children?
Well, I mean, yeah. So Robin,
Program.
it's a really good question. So most of their stuff is aimed at secondary school, but they've got quite a few mathematics resources, which are really aimed, for example, learning fractions, learning addition and subtraction, and so on. So the mathematics resources go much lower. The other thing is, from a conceptual point of view, like if you look at that rubbing the balloon on a jersey, that you can discuss with a primary school class, even if they don't understand protons and electrons, at a conceptual level, or discussing why when you walk across a carpet and rub your feet, you get a shock from the doorknob. So things like that can be discussed at a much lower level. I've shown you a couple of the physics sims. There's about 120 physics sims. There's also extensive chemistry sims, which are great. There are mathematics and a few biology ones and earth science. And PHET is adding to them all the time. But really, I would suggest go to the website and just explore. Okay. Thanks, Robert.
That sounds interesting. I'm a biologist, so I definitely will look at the biology.
So have a look at the biology. The one, again, I'm not a biologist at all. I gave it up in Standard 7 very gratefully. But, my colleague at the Science Center has done a series of biology videos. The one that works very well is this one on natural selection, where you can actually set up different population groups. I think they're wolves, rabbits, and bushes, and then just see what happens under different conditions. The mathematical model, it's really fun. But don't let me tell you about it. Just go to PHET and explore it. They're really great. Thank you.
Thanks, much appreciated.
Thanks. I see Denise had her hand up, Krishni.
Yeah, before we go to Denise, can I ask Carol's question, please?
Sure.
She says, I have a question. How do we integrate this virtual learning and wonderful use of innovative resources with practical hands-on? So it's the hands-on, minds-on, once again.
Yeah. So, Carol, all I can say is hands-on is best. I have an interactive science center with over 200 exhibits, which are gathering dust because of COVID, and it's an absolute tragedy. Hands-on to the real thing is always better than a simulation or a computer-based experiment. All the research shows that if the experience is mediated through a black box like a computer, it's just not quite as believable, is it? And mechanical interactive, where you pull a lever and something happens in front of your eyes, you can try it under all kinds of different circumstances, really is best. But Carol, the reality is, when I look at the rural Zululand schools that I work in, none of them are doing classroom practicals with a whole class taking part with multiple sets of equipment. Very few are even seeing teacher demonstrations. I want to say to teachers, if you're still teaching live, please at least do demonstrations. And those can be very interactive, especially if you stop before doing it and say to the children, what do you think will happen next? Okay. The hands-on is always better. In many ways, PHET is responding to the fact that schools don't have equipment, pupils don't have equipment, and also with COVID, they can be used online. So I would say you can integrate them, but I'm saying, like, if you could do a live electricity experiment, then don't do the simulation. Rather do the live one, obviously, as long as it works. So choose the live ones first. But I'll go on, I'll talk in a minute about the photoelectric effect on PHET. It's a really difficult experiment to do practically. Needs expensive equipment. It's difficult to get it to work. But on PHET, it's just fantastic. And it really is easy to follow and to understand. Thanks, Carol.
Thanks. So Derek, I think, the opportunities you have to manipulate variables and quantities that PHET, gives you is really awesome. So even though, the hands-on is always the best, but I mean, projecting into the future, learners may just be very comfortable learning from a box. So that's possibly the way we're going. But yes, you're quite right.
I would agree, but the problem is one still has to have experience of the real thing, and I also think if you have done a hands-on experiment and experienced the real thing, then it's okay to continue with the box. But if the box is the only experience, I think that would be very sad. I think it's really important to get experience of the real thing.
So Derek, another point, this interactive simulations, it's awesome. However, it does not replace the teacher.
Absolutely not. Yeah.
Absolutely not.
Yeah. So these interactions are there to be used by teachers or used by pupils. I almost don't like integrating them into my videos. And I see there's a comment also from Angela, also made lots of videos with PHET. They do work well in videos, but it's much better. As you say, the teacher can manipulate variables. And then I love using PHET to answer questions. So if a pupil says, what would happen if we did this? Even if I know the answer, I would say, well, I don't know, let's try it. And this idea that science finds answers by performing experiments, not just by having this massive body of knowledge which never changes. So it really does not replace the teacher, and a good teacher will use these PHET simulations. What is great, though, is for children to use them for discovery learning. And it's fantastic for pupils to be able to do these what-if experiments by themselves with no fear of failure. Okay, and just explore and see what happens. You saw in my last experiment, the battery caught fire. Now, that would be a disaster in the classroom, but it was quite fun on screen.
Thank you, Derek. Janice, will you unmute, please, and ask your question?
Hi, yes. I've got sort of two questions, but I think the one has already sort of been answered. I just wanted to know how easy it is to put these simulations in a PowerPoint presentation or a video if you want to create your own sort of resource. And then the other thing is, because I'm in the Northern Cape, about more than 90% of our students are Afrikaans.
Yeah.
And most of the resources available out there is in English, and it makes it extremely difficult to to communicate with them or to show them these resources, because you can show them the English ones, but it's just above their language. It's a big language barrier. So yeah, those are my two questions.
Yeah, so that's a really important question. So Denise, have you used PHET before?
Yes, I have. I'm quite familiar with it. Yeah. Yes, so it's very nice. Yeah,
it's almost completely language independent. And in fact, sometimes I go to a new simulation and I'm a bit frustrated because I don't know what to do, but they want you to actually explore by yourself. And it's so much better. That's real experimentation. And, almost everything is done symbolically. And, really, there's very, very little language at all. And in fact, PHET is working on something now, whereas if your mouse hovers over something, it'll actually speak the words to you in your own language. So they're working more and more to try to make it language independent. I couldn't agree with you more. And that's why, as I say, for your pupils to watch my English videos, it'd be much better for them to hear from you speaking their home language, or whatever that language would be. So the nice thing about PHET is they are so adaptable. They're a tool in the teacher's hand, and the teacher can make of it, whatever they particularly want to do.
Thanks, Derek. I think the most important word you said in that sentence is tool.
Yeah,
It is a
absolutely.
tool. Yeah. So we have a question from Becky. I think you covered this, but perhaps you could just repeat yourself. Is there a mobile app for PHET, or is it only accessible via the internet? Derek,
Krishni,
have
I've
you
lost
muted?
you.
Okay. All right.
I'm here, but I lost you
Okay.
for a minute. Please
All
repeat
right.
the
Okay.
question.
So Becky asks, is there a mobile app for PHET, or is it only accessible via the internet?
So I have to say to you that I honestly don't know, but all I can say is just Google it, find out. And remember, you don't have to be on the internet. You can download it, and then it's freely available. What I want to do, because I think I've sorted out my multiple screens that were confusing me here. So what I want to try to do is just show you the PHET app. So let me just share here.
But you did say they're downloadable.
Yeah, so you can download the whole lot, so you don't actually have to go at all.
Stay
So
online.
are you seeing the index of SIMs here, Krishni?
Yes.
Okay, so this is the new PHET download. It's about 200 meg. Just remember to click all the SIMs so you get the different languages. And you can see as I scroll through, there are literally hundreds of them here. And this is across all. So if you go to their website, it's more searchable in terms of physics, chemistry, biology, and so on. But you can see there are just so many of them here. Now, what I'm showing you now is on my laptop. If I disconnect it from the internet, I would still be able to use all of these. And sorry, I didn't answer the previous speaker. PHET now also has something where, I can't remember exactly what it's called, but again, you can just Google it, where you can actually embed a PHET simulation into a PowerPoint slide. And then when you run your screen show, that simulation will be live and you can actually manipulate it during your PowerPoint show. I want to tell you the videos that I made, I simply made using Zoom. I had a Zoom call with myself, with my talking head in the corner, and I recorded it. And I simply made the videos like that. And then whatever content was shared, whether it was PHET or something else, that was part of that. Okay. Krishni, shall I continue a bit?
Can I just ask one more question from
Please,
Abdul?
yeah, go ahead.
Okay, so I'm just going to read it out.
Okay.
Perhaps if you need clarity, Abdul can unmute and ask himself. So he asks, are there any SBA tasks, school-based assessment tasks, using PHET, using for physics in the FET phase? And you did mention this is an American simulation, but however, the concepts are the same.
Yeah. So look, I mean, obviously it hasn't been mapped exactly onto the South African syllabus because it's used in 100 countries around the world. And I think really it's up to teachers to go. Again, I don't know what the education department would say, whether they would accept an SBA task done on PHET. I would say it's more valuable rather than performing quantitative experiments, rather to actually present topics. I think that would be more valuable.
Okay, there is a comment. PHET is also available on Play Store at R12.99.
Okay, great, excellent.
Derek, can I just
yes.
Point out, and maybe you could show it on the screen, that there are also worksheets that teachers throughout the world have developed and that you can download and use, because perhaps that will also help the person who's asking about the SBA tasks.
Absolutely, absolutely. So yeah, I mean, there's you just, I can't show you everything today. Just go to the PHET website and there is so much available there, and including worksheets from all over the world. Krishni, let me continue with a couple of things and then we'll come back to some questions. Is that all right?
That's fine. We only due to leave the session just before 14:50, but because we've been taking questions in between, it's fine. Go ahead. Thanks.
Yeah. Okay, so I want to show you another of the PHET SIMs, and I just need to find my, okay. So As I say, PHET seems more difficult to use than it should because I'm having to do screen sharing, but the screen sharing is the only difficult part. PHET is really easy. So I'm just going to open up the photoelectric effect.
I can see that.
And it should be opening. Just give it a second. As I say, sometimes it might be different on your computer. There's sometimes issues around Flash or Java, but that will just depend what you've got loaded or not loaded on your particular computer. So photoelectric effect is normally taught in the 3rd term of grade 12. In many ways, it's very theoretical. Just think it took Albert Einstein to actually change the world's thinking around to the fact that light was not just a wave, but also had a particle effect, to talk about photons, E equals HF, and so on. So it's a very difficult concept in many ways for pupils to understand. So here's the photoelectric effect sim. And Krishna, are you seeing the light bulb and all the different bits here and the battery?
Yes, I can.
Okay. So you can change the frequency of the light here. So let's start off on the red side, and I'm going to turn the light on, turn up the intensity. So the light's shining on my target plate, which is sodium here, but you can see absolutely nothing's happening. And basically that's because our frequency is below the threshold frequency for sodium. If I increase the frequency, so you can see the light changes through red and orange, yellow, green, turquoise, blue, indigo, violet. Now you can just see some electrons starting to come out. So we've gone above the threshold frequency, and now some electrons, some photoelectrons are ejected from the plate of sodium, and they can travel across. And you can see a current is actually flowing here. And the higher the frequency, the more energy those electrons have got. So they actually start to move a lot faster there. Now again, the intensity, if I turn the intensity down, what you see is they move just as fast, but you've got fewer of them, and consequently that current over there actually goes down. Now, what I particularly like about this is photoelectric effect is so often examined in terms of the graph. And we can actually turn on the graph here of electron energy versus light frequency. And this is the graph that's very commonly asked in matric. If you look at the 2020 question, they had 3 of these graphs together on a page. So there you've got frequency, which is really just color. At the moment, we're on red light. And then you've got energy. So it's basically the maximum kinetic energy of the ejected photoelectron. Blue dot. Unfortunately, this graph doesn't get much bigger, but just watch that blue dot. So as I increase the frequency, you'll see it moves across the x-axis, because of course the frequency is increasing. But of course, kinetic energy of the photoelectrons is 0 because none are being emitted. So it keeps moving. When we reach that threshold frequency, you can now see how that blue dot starts to go up. And there's a linear relationship there. And of course, your teacher should know that the gradient of that graph is just h, Planck's constant. Now note we can see the threshold frequency there for sodium was probably about 0.6 times 10 to the 15 hertz. Let's go down again and let's actually change our metal. So let's go from sodium to maybe copper. Okay. You notice how nice their programming is. The color of the metal has changed to copper color. Now watch that blue dot again. Remember where the threshold frequency was before. Now you see it goes along the x-axis for much longer. We're through to purple. There's still no ejected photoelectrons. It's only when we get quite deep into the ultraviolet here that there you can see ejected photoelectrons, and the graph starts to go up like that. So, you know, it's really useful to be able to show these things. I'm just quickly looking at my booklet here. From the photoelectric effect from last year. And I don't know if you can see on the screen, but this is the question from 2020. And it's exactly this graph. It's 3 different graphs for 3 different metals with 3 different threshold frequencies and work functions. And it's really, you can see this is such a fantastic way to explain it. And it really makes it clear. This is a very difficult experiment to do live. I wonder if any of the teachers are able to, but I just think the simulation is so great, explaining the difference between frequency and intensity here and the effect that they have. And you can see so clearly your cutoff threshold frequency and the different things like that over here. So I'm just going to stop that share over there. I just want to share one of my other favorite sims. And as I say, there are so many that it's really very difficult to actually choose one. Okay, so I'm just going to choose one called the moving man, which is really great for when you're doing graphs and equations of motion. That's just starting up there. Now, I think I'm going to need to do a new share here. Okay, so Krishni, just confirm that you've got a mostly blue screen with a man in the middle.
Yep.
Okay, great. Sorry to have to keep asking this. So basically what you can do is you can move this man around and you can see how position, velocity, and acceleration are affected. You can also ask it to switch on the vectors. And so as you move him around, you can see those different vectors. What you can do as well, let's just stop it and reset everything, is we can give some preset values. So we can say, right, let's start him at minus 10 meters. Let's give him a velocity of 2 meters per second, and let's give him an acceleration of minus 0.5 meters per second squared. Let's put in the vectors, and then let's allow him to go. And you can see how that motion is affected by the velocity and the acceleration. Now, this is nice from a conceptual understanding point of view, and there he hits the wall. But what's much better here is actually, sorry, I'm just trying to move my screen here. What's much better is actually to go to the charts. So now you've got the graphs of position, velocity, and acceleration. So let's do that again. So we can give him an initial position of minus 10 meters all the way to the left. Let's give him an initial velocity of, say, 6 meters per second and an acceleration of minus 1. And of course, what the pupils need to be able to do is to draw simultaneous position, velocity, and acceleration versus time graphs. Now we can run the system and you can see two things. You can see the man physically moving, but you can also see the graphs being drawn at the same time. So it's really useful to be able to link the two conceptually. Okay, now I can do a playback. I can ask it to switch on the vectors. And once again, we can go and I can slow it down. So you've got a slow motion, fast motion here. So I can play it back here. And for example, I can stop it just at the highest point of that position time graph. And you can see when he's furthest from home, velocity is 0 because he's changed direction. Now, this scale needs to be enlarged a bit on the acceleration graph just to be able to try to see. But you can see we have actually got a slightly, there we go, there's a slightly small negative acceleration. If we get rid of some of the other graphs, you can see that the position time graph is a perfect parabola there, and we can allow him to move. And again, you've got that fantastic feedback of seeing the actual moving object, seeing velocity and acceleration vectors, and seeing the graphs being drawn simultaneously. Now, again, the only way to learn to use this is just to play around. But you can see the tremendous potential for teaching graphs of motion through this. Again, I'm just going to stop my share a bit. And I'm going to go in a slightly different direction away from PHET after this. So I just wonder if there are any more questions or discussion about this before we move on. Thanks, Krishni.
I don't see any at the moment, Derek, but I have a question.
Sure.
You know, like me, you're familiar with both platforms, and it's very different. But do you want to explain to everyone the difference between PHET and Khan Academy? What could you get from either of them, both of them?
Okay, so Khan Academy has pre-recorded videos. So you would go there and it's like going to YouTube. You'd watch a pre-recorded video. Now, in my last session, I talked about the pre-recorded videos that I have made for matrics. And of course, you know, you can only use what is there already. With PHET, it's a tool. So to me, Khan Academy is like a library. You can take out a book and you can read it. But PHET is like a tool. And you can use it in any way that you like. And I keep finding new ways to use PHET. One of the things that I've done is integrate it into every single lesson that comes in the book. One of the things I want to mention is with my videos, they are designed to be used with the booklets. So, for example, the particular page, I hope you can see, tricky with the camera, but this is on work, energy, and power. And the picture there is a screen grab from PHET. So we use PHET. The energy sim is really nice to actually explain it there. So as I say, PHET is not a video. It won't do anything unless you make it do something. You need to put in initial values. You need to change things around. And I think it's far more powerful. So for the teacher in the Northern Cape, for the teacher, maybe you need to explain things in isiZulu, or needs to explain things more slowly. With PHET, the tool is yours. You can do whatever you want with it. So there's great value with Khan Academy, with the videos I've put out. But you know, there it's pre-programmed. You can't really change it around. And in terms of doing investigative learning, I think PHET is just so much more powerful. But they're different and they have different purposes. PHET is not ready to teach content. I think it's very valuable in terms of illustrating content, but I wouldn't use it particularly to teach. While I mentioned that energy one, let me show it to you quickly because I think it's really great. So we go to energy skate park. Okay, I think I'm going to have to change my share as well. Give it a chance. And as I say, doing PHET through Zoom is actually awful. If you can do it live in your classroom, it just works so much better. So, Krishni, confirm if you got the energy skate park, the black screen?
Yes, I can. Thank you.
Okay, so let's go to the intro. And so here you've got a skateboarder, and you can put your skateboarder on here, and your skateboarder can go up and down. Now, what is really useful when you introduce energy and you're teaching about kinetic and potential energy is we can switch on the energy graphs here. And can you see how these graphs actually change? And let's put it into slow motion, and I can pause it. So at the top of the rise, the total energy is just potential. At the bottom, at the lowest point, if I can stop it there, you can see the total energy is kinetic. That energy is changing from kinetic to potential energy. Now, the only force acting here is gravity. You can see I've switched friction off, which of course is very unrealistic because in the world we always have friction. And gravity is a conservative force. Now, teachers, you know how difficult it is to teach non-conservative forces and the effect on energy, but just watch this. Watch what happens when I switch friction on. Now you're going to see practically the skater's not going to rise as high. I've still got on slow motion. So instead of going to the top, she stops there. Now can you see there's a third graph here for thermal energy? And that's the heat that's generated by the friction between the wheels and the track here. Now you can see the kinetic and potential are getting lower every time. And the thermal energy, let me put it back to normal speed, thermal energy just keeps growing. And eventually, we all know this happens. Everything runs down in the world because friction takes away the useful energy and turns it into non-usable forms. So this non-conservative force of friction, eventually all that kinetic and potential energy is gone, and it's all been converted to useless thermal energy. Now, you can go to the playground and you can design exactly whatever track you want. And again, no one needs to show you how to do it. Just go there and play. And you can join different things together and make different shapes and sizes. And then you can put your skateboarder on, switch on the energy graph. So this is obviously a bit more complicated, but you can see how the energy is changing now. And of course, it's not going to zero of potential energy. I can change things here. But you can see, and once again, as soon as we turn friction on, that non-conservative force, look what happens. She doesn't go quite so high. Eventually, she can't get over that one. And you see that thermal energy is growing. So what a great way to present energy. And, you know, when you discuss it, instead of just, don't go to equations too early. All the research in physics education shows that we should first have a conceptual grasp of something before rushing to plug into an equation. So that's the energy skate park. Okay, pause there again. Questions, comments?
None at the moment, Derek. I don't see any questions in the chat or hands.
That's fine. So I'll just go to a couple of others. Now, PHET is fantastic, but it's not the only thing. So let me just share another screen with you. Gosh. Okay. Now, again, if you just follow, I've just Googled Java Lab, and if you just Google Java Lab, it's a great site, and it's got all kinds of fantastic simulations. Now, some of your computers might have problems with Java. I'm afraid that's something that you will have to sort out, but just Google Java Lab, it'll take you here. This is what Java Lab looks like. And they've got all kinds of simulations. These can't be downloaded. You have to stream them live, but you can see, again, all kinds of different topics. And again, some of them are just very pretty demonstrations. So let me put Newton's Cradle on. Unlike PHET, Java Lab does have a little bit of advertising on it. So sometimes things take a minute or two to load, but just bear with it. But there's some really nice, again, simulations of things. And the program has been done very nicely. So you will have to put up with a couple of adverts, but it is busy loading. Just give it a second. Here we go. And I can also make that full screen. So here you've got a Newton's Cradle, and we can pick up one of these balls and let it fall. And you can see, isn't that a beautiful simulation? And they even have the movement of the other balls. And then we can do a what if with the class. And we can say, right, we picked up one ball and one ball was knocked off. What would happen if we picked up 3 balls? Okay. And then hold it there, have some discussion with the class, and then let it go. And you can see then 3 balls come out because of simultaneous conservation of momentum and conservation of kinetic energy. So that's a great sim which is available. And as I say, there are so many of them here. I'm just going to pop over to another one of them. So I wonder, let's go to gravity difference. I wonder if anyone is feeling bold enough to pop into the chat what their mass is. What is your mass? Mine's 85. Anybody feeling bold to tell us what their mass is? We got anything coming in, Krishni? I can't see the chat. Sorry?
There's a 53 and there's a 102 and a 68.
Okay, 102 is much more exciting. I'm going to go with that one. Okay. So here we go. It only allows 100, so let's go with 53. Okay, thank you for all these honest people. Now, of course, people are always talking about how to lose weight. And of course, weight and mass are different things, aren't they? And so what we're talking about is your mass. And of course, your mass doesn't change anywhere in the universe unless you cut off an arm or something. But if you stood on a bathroom scale, a spring scale, that's actually measuring your weight. In fact, it's measuring the normal force. So let's see someone who had a mass of 53 kilograms on Earth. If they visited Mercury, that'd be a good thing. You stand on the scale, suddenly you're 20 kilograms. The figure in brackets is the acceleration of gravity on Mercury. If you go to Venus, you don't really gain much, 48 kilograms, losing 5 kilograms, not that great. On Earth, of course, we are 53 kilograms. Let's go to Mars. It's a small planet, 20 kilograms. Good place to go. If we go to Jupiter, this huge planet, you'd be 134 kilograms. Saturn, 56 kilograms, not very different from Earth. Even though Saturn's big, it has a very small density. Saturn would float on water if we could find an ocean big enough. And we can look at a whole view and see all the different things. So it's a really fun one in that, again, you can do this what if. So what if my mass was this? What if my mass was this? And so on. So look at gravity on various different planets. I've got another sim here. And again, let me just make sure that you've got, so Krishna, you've got a mostly yellow screen with
Yellow
a generator
screen.
on it?
Yeah.
Sorry?
So before you start, there's quite a few people now who want to move to Jupiter and Mercury and other planets. But I must say that mass and weight are the 2 most commonly, confused concepts. The misconceptions between mass and weight. It's persistent over the years.
Absolutely. Yeah, absolutely. And again, using a simulation, and again, there's lots of others in Java Lab and also in PHET that deal with mass and weight. We just don't have time. Can I continue with this one, Krishni?
Yes, perfect. Thank you.
So you've got a mostly yellow screen with a generator on it?
Yes.
Okay. So one of the things we teach in Matric is the difference between AC and DC generators. And again, of course, it's great if you can have a real example of each, but you're probably unlikely to. So here we've got an AC generator. It's got no commutator. It's just got slip rings. And there you can see the voltage output. So you'll see this is rotating very slowly, but still you've got a sinusoidal output there, voltage going high and low. You can see the needles going backwards and forwards. And we could turn magnetic fields on and off, induced currents on and off, and direction of movement. Now, an interesting question, and again, you can do a what if question, is it's rotating 3 times per minute. How would that graph change if it rotated 6 times per minute? So think about it a bit before I go ahead. And of course, 2 things change about the graph. So let me change it to 6 rotations a minute. Okay, now can you see the period has changed? And also the amplitude has changed, because the faster you go, the higher the voltage again. If I change to 12 rotations per minute, again, the period has changed and the voltage output or the amplitude has changed. And it's a really nice way to show that. And of course, in an instant, and of course, I can change direction. I can make it turn the other way around. And I can put a split ring commutator on, and suddenly I've got a DC. So you've got your split ring commutator there. Watch the direction of current in that it stays the same. Apart from the short time when the current is blocked. You can see that the voltage here is only positive now. Now again, what a great way to show how these work. It's so much more effective than a simple static 2-dimensional diagram in a book. Okay, I'm just going to share one more thing, because I think, Krishni, I can see our time is just about up. Now, you can also do real live experiments. And I want to change. Krishni, are you seeing an oscilloscope on screen?
Yes, I can.
Okay, so now this is not a simulation. It's important to stress that this is a real live experiment. And I've got my microphone here, and this is a program called Data Studio from Pasco Scientific, and it allows you to look at sound waves. If I keep quiet, very small, and if I speak loudly, you can see the sound waves become very tall. And what you can do is you can investigate lots of different things. If I play a recorder here, for example, you can look at the really interesting sound pattern of that recorder. In fact, just about the purest musical note you can make is by whistling. So have a look at this. This is what music looks like. And if I freeze that, look at that perfect sine wave, and at the bottom, just a single frequency. So that is music, and this would be the equivalent of a laser beam, just a single color, single frequency. When I switch the microphone back on, I can analyze all kinds of sounds with this, musical instruments, loud sounds, soft sounds, and so on. It also has a sound creator, which enables me, just a sec, particularly if I switch on share sound, which enables me to manipulate the wave, make it taller and smaller, make it wider, and so on. So the real, let me turn that off. The real joy about all these experiments and simulations is that you can manipulate them in real time. So yes, you can use them to make videos, but I really think it's much more valuable to actually, as a teacher or for the pupils, to allow them to be manipulated. Now, there's tons more that I could say. So many of these PHET videos are incorporated, simulations are incorporated in the videos that I've made. So if you're in the previous section, get hold of those or just have a look at them on one of the links that I sent. And then I hope you'd be encouraged to use these yourself as well. Krishni, I'm happy to take any further questions if there's time. Thank you.
Okay, we have a few minutes for just a few questions, but I just, I must say that the curves were really, really perfect and also beautiful. So I think the ladies should appreciate the next time they get whistled. There's just one request, web address of this, please.
Of what?
I'm assuming
Sorry?
for PHET. Yeah.
You know what? I don't believe in giving web addresses. Just Google PHET. It'll be the first hit. It's much easier.
Derek, I don't see any more questions or comments.
Okay, unless somebody wants to ask one. Eric Mapumulo has a raised hand.
Yes.
Hello.
Hi, Eric. Go ahead. Unmute, Eric.
Hello, can I speak? It's Abdul here.
Yes, you can. Oh,
I just
Abdul,
want to
okay.
know the last demonstration with the oscilloscope. I just want to know the name of that.
Oh, sure. Okay. So just to tell you, that is not free software. There's an American company called Pasco Scientific who makes fantastic interfaces that allow you to connect, basically to do experiments and gather. They're basically data logging equipment. So in South Africa, they are marketed through PERT Industrials. I'll put a contact email for Peter Hoshofsky in the chat. He's the local agent. So as I say, you know, that's something you would have to buy, but I have to say from my use of them, well worth the money. And again, you can find a interface for motion, for voltage, current, temperature, pH, whatever. They have everything.
Eric, go ahead. Eric is unmuted. Go ahead and ask your question. Okay, I'm not sure what's happening there. Eric, if you can hear us, maybe you want to type it in the chat quickly.
And again, you know, I'm very happy to continue this conversation with people afterwards, but you know, really, you don't need anyone to show you PHET. The best person to show it to you is you yourself. You must go and explore it.
Yeah.
And it's fantastic.
Yeah, you got to do it yourself. That's the only way you. Yeah. All right. So thank you very much, Derek. There were lots and lots of thank yous and wows in the chat. So thank you very much. Thank you very much from all of us. We'll meet up again in the plenary in a few minutes. Thank you so much.
Thanks for joining, everyone. Cheers.
Thank you. Bye.
Chrisney, can I just request that our technical support team just paste the link again for the plenary session in the chat box to everybody, please?
Yeah, before you go.
Thanks, Edna.
Thank you for all the kind comments in the chat.
We're still waiting for that link.
Derek, may I say something? It's Carol here while
Yes,
we wait for the
Carol.
link. Hi.
Sure.
Derek, you know what I'd like to say? First of all, it's just amazing. This whole, to everybody, this whole session, this whole conference is just so inspiring to everyone because of the shared knowledge. And it's so amazing how every year you come up with something that we didn't know the year before, and every speaker. So it's lovely to see all the old faces, but really how amazing this interactive PET thing is phenomenal. And also in this period of COVID, and I am very worried, what are these learners going to end up being because they've never touched anything? I feel like we're going so backward. To go forward, we're going backward. And with 4IR coming in, let us please never lose sight of the fact that you've got to touch the ball and kick the ball to be the star of football. And so it is with education. But the thing that we need to take note of perhaps is that this is the time for us to upskill and work with teachers in these virtual sessions. I think that the value that we can all give to everyone in this room and to the teachers is probably of more importance than to the learners, because this is just mind-blowing. Thank you.
Yeah, you know, I think one of the good things about lockdown, if there was one, is that it's forced many of us to explore new areas. You know, I hadn't done any video work till a year ago, and you know, now I've done a huge amount. So I think that's great. I still want to stress what you said again, that hands-on is always best. You know, and we can learn through the tablets and screens and so on, but it never replaces actual hands-on. So we must use it as a supplement, but not a replacement. So everyone, the link is in the chat. So you click on there and go back to the main webinar.
I just wanted to say nobody wants to leave the room, so you need to please click on the link and leave. Thank you.
Everybody go, please. Goodbye. Thanks.
Thank you, Steve. And thank you, Derek.
Sure.
For those of you who are still in the room, if you are struggling, copy and paste the link into your web browser to go back to the plenary session. Thank you.